This time, I'm going to talk about confusion matrix for machine learning. What is a confusion matrix? A confusion matrix is an n times n matrix used for evaluating the performance of a classification model, where n is the number of target classes. The matrix compares actual target values with those predicted by the machine learning model. This gives us a holistic view of how well our classification model is performing and what kinds of errors it is making. Let's take a look when n equal to 2. We have actual values, positive or negative, and also we have predicted values from our machine learning model. It is either positive or negative. If the actual value is positive and our predicted value is also positive, so this is true positive. And in the same time, if actual value is negative and the predicted value is also negative, this is true negative. So in those cases, everybody is happy because machine learning model provided us the correct answer. But if the actual value is negative, but the model predicted the value is positive, it is called false positive. Similarly, if the actual value is positive and the predicted value is negative, it is called false negative. So in those cases, the machine learning model provided us the wrong answer. When our model made mistakes, there are two types of errors, type 1 error and type 2 error. Type 1 error, it is when we have false positive. That is, the model tells us it is positive, but the actual value is negative. Type 2 error is when we have false negative. That means, although the actual value is positive, the model told us it's negative. So it is false negative. Let's take a look at an example. Suppose we had a classification data set with 1,000 data points. So the true positive is 560 and the true negative is 330. So all those values are correct. And in the meantime, we have false positive 60 and we have false negative 50. In this example, it is a pretty decent classifier for our data set. And how can we evaluate the result of the accuracy? We use this accuracy measure to show how accurate our model is. That is, in the numerator, we consider the correct cases. So we will add true positive and true negative together. And in the denominator, we will consider all the cases, including the wrong answers. So in this example, we will have accuracy 890 divided by 1000. So it is 89%. So this is a pretty good accuracy. So the measurement accuracy can be used to evaluate our model. Besides accuracy, there are two more measurements we can use to evaluate our model. They are precision and recall. Precision tells us how many of the predicted cases actually turned out to be positive. In this case, we will consider when we predict the value is positive, and among those our predictions, how many are true positive. So precision equal to true positive divided by true positive plus false positive. So when we calculate precision, we consider this direction. Precision is important in music or video recommendation systems, e-commerce websites, etc. For example, if you go to Amazon.com, you might browse all kinds of products, and Amazon will try to predict what kind of products you are interested in. Among all those predicted products, Amazon wants to know how many are the products you are truly interested in. That is the measurement of precision. Another measurement is called recall. Recall tells us how many of the actual positive cases we were able to predict correctly with our model. So, among those actual positive cases, we want to know how many of our predictions are correct. So the formula is true positive divided by true positive plus false negative. Recall is important in medical cases where it doesn't matter whether we raise a false alarm, but the actual positive cases should not go undetected. That is saying, we really don't want to predict a person is healthy when the person is really sick. So, when you don't want to ignore an actual positive case, you should use measure recall. How do we consider precision and recall at the same time? In this case, we will use F1 score. F1 score is the harmonic mean of precision and recall, and so it gives a combined idea about these two metrics. When the value of precision is equal to the value of recall, F1 score will reach its maximum value. In Python, there are two functions, confusion matrix and classification report. When we generate classification report in Python, there are two concepts in this package. Macro average is the average of either precision or recall or F1 score. So it's just the average of all those values. And the weighted average is the weighted average of either precision or recall or F1 score. Now let's go to Python to see how we use those functions. First, we will import those functions. And we have actual value here, and we have predicted value here. Altogether, we have 10 values here. And we will calculate confusion matrix and check all those values about true positive, false negative, false positive, true negative, and then we'll generate our classification report. Let's run the code. You can see true positive is 2. So let's take a look. Actual value, this is positive, this is positive, and this is positive, this is positive. But when we do the prediction, we have those 3. And the first one and second one, they're correct. So those are true positive, is 2. How about true negative? We have negative here. 1, 2, 3, 4, 5, 6. But how many did we detect? We detect 1, 2, 3, 4, 5. So true negative equal to 5. And similarly, you can check the false positive. False positive means our prediction is positive, but in reality, it is negative. So our prediction here, we are saying this is positive, but actual value is negative. That's why false positive is 1. How about false negative? That means the model thinks it's negative, and in reality it's positive. So here we think this is negative and this is negative, but the actual value is positive. So false negative equal to 2. And in this classification report, for 1, we have 4. That's the meaning of support. So 1, 2, 3, 4. And for 0, we have 6. And the precision you can calculate is 0.67. And recall is 0.5. F1 score is 0.57. Because we only have 2 possible values in this example, so it's very simple to calculate all those measurements. You can just calculate with your calculator. And as we said, macro average is the average of either precision or recall or F1 score. So you can see if we take average of 0.67 and 0.71, it gives us 0.69. That's the average. And how about weighted average? In this case, we will consider how many supports we have. And this 0.67 will times 40%, and this 0.71 will times 60%. And because this is 0.71 has more weight, and weighted average shifted to 0.70. You can use calculator to verify that. In this example, we have only 2 possible values, 1 or 0. So if you want to calculate confusion matrix, maybe you don't even need to use those functions. You can just calculate manually, and it is not difficult at all. But if you have, say, 20 or 30 or maybe 100 possible values, and it's better to use those functions, and they will calculate the classification report for the confusion matrix for you. This is my brief introduction about confusion matrix for machine learning. Please provide your comments and subscribe to my channel. Thank you for watching.